Okay, let's be real. If you've ever tried to learn about the human body, you know it's just this massive world of complicated terms, processes, and numbers. It can honestly feel like trying to drink from a fire hose. Right? Red blood cells, white blood cells, coagulation cascades, electrolyte balances. The list just goes on. And that feeling of being completely buried in information, yeah, that's totally normal. But what if I told you there's a smarter way to learn all this stuff? A way to turn that mountain of facts into simple, memorable phrases you'll literally never forget. Today, we're going to break down some of the toughest topics in biology using these amazing memory hacks called mnemonics. So we're going to start small. And I mean really small. We're going down to the level of a single cell, which has to perform this incredible balancing act with its electrolytes just to stay alive. I mean, just look at the difference here. It's not even close. Sodium is way, way higher outside the cell, while potassium is massively concentrated on the inside. And this difference, this gradient, it isn't just some random piece of trivia. It's the engine that drives everything from your nerve impulses to your muscles contracting. It's absolutely crucial. So here's the million-dollar question for every single biology student. When you're in the middle of a test, how on earth do you keep that straight? Which one's high inside and which one's high outside? You do it with this simple and, okay, slightly absurd phrase. Just get this picture in your head, a single salty banana. That's it. That's the whole key. Here's how it works. The salty part, that stands for sodium and chloride, is on the outside of the cell. You know, just like you'd put salt on the outside of a pretzel. And what's inside our salty snack? The banana. And what are bananas famous for? Potassium. So potassium is on the inside. Salty outside, potassium-rich banana inside. I promise you will never mix those up again. All right, let's zoom out from that tiny single cell to a much bigger, much faster process. The moment you get a cut, your body launches this incredible 3-step emergency response. The whole process is called hemostasis, and it has to happen in a very specific order. So first, bam, the blood vessel constricts in a spasm to slow the bleeding. Second, these tiny cell fragments called platelets rush to the scene and form a temporary plug. And third, the big guns come out. A complex chemical reaction called coagulation creates a tough, durable clot. But again, when you're under pressure, it's so easy to get that sequence mixed up. Does the plug come first or the spasm? How do you lock in that exact order? It's easy. You just remember that your body forms a very powerful clot. V is for vascular spasm. P is for platelet plug formation. And C is for coagulation, the final clot. Very powerful clot. So here on the left, you can see the V in action. That's the vascular spasm, where the blood vessel itself squeezes tight to reduce blood flow. And then on the right, you see the P, the platelet plug, where all those platelets get sticky and pile up to form a temporary patch. And here it is, the grand finale, the C for coagulation. This is the real deal. A protein called fibrin weaves this amazing, strong mesh over that platelet plug, trapping red blood cells and creating that stable, powerful clot that stops the bleeding for good. Now, if we were to zoom in on that coagulation step, whoa. It looks like a crazy subway map, right? It seems super intimidating, but don't worry. We can hack our way through the most important part. Let's just focus on what's called the common pathway. This is the final stretch of the road where all the different signals meet up to actually create the fibrin mesh. These are the 3 final steps that have to happen. And to remember this final critical sequence, just imagine a professional who throws fibs. I know, it sounds ridiculous, but just stick with me because it maps perfectly onto the biology. Here's how it works. Pro stands for prothrombin activator. That's the enzyme that kicks this whole party off. Throws is our little trigger word for thrombin, the next crucial enzyme that gets activated. And fibs, well, that's for the final fibrin mesh that gets woven to complete the clot. Pro throws fibs. Done. Okay, time to switch gears. Let's move from fixing injuries to fighting invaders. Your blood is crawling with this amazing army of different white blood cells, or leukocytes. But here's the thing, it is not an army of equals. They're not present in the same numbers. Just look at this breakdown. Neutrophils make up the vast majority of your white blood cell army. Then you've got a decent number of lymphocytes. But way, way down at the bottom, basophils make up less than 1%. Remembering the order from most abundant to least abundant is a classic biology headache. So how are you supposed to memorize this list?
neutrophils, lymphocytes, monocytes, eosinophils, and basophils in that specific order of who's most common.
Well, you do it with what might be the most famous mnemonic in all of biology. You just have to remember this one critical piece of advice. Never let monkeys eat bananas. It's perfect, isn't it? Never for neutrophils, the most common. Let for lymphocytes, monkeys for monocytes, eat for eosinophils, and bananas for basophils, the least common. It's just a simple sentence that perfectly organizes your immune army from the biggest battalion down to the smallest. You know, a salty banana, a powerful clot, and some dietary advice for monkeys. These aren't just silly phrases. They're stories. And our brains are just naturally wired to latch onto simple, sticky stories far more easily than a dry list of facts and numbers. These memory hacks prove that any complex subject, no matter how intimidating it seems, can be broken down and mastered. So the only question left is, what complex idea will you find a story for next?